Hello everyone, I'm Roshni from MATLAB Helper. In this video, we'll be seeing about the mapping toolbox, which is one of the very interesting toolboxes in MATLAB. Let's see how we can utilize its features and also implement in the coding. Mapping toolbox. First, let's see what a mapping toolbox does. This toolbox provides algorithms, functions, and an app for analyzing the geographic data and creating map displays in MATLAB. We can import vector and raster data from a wide range of file formats and web servers. Geospatial data can be combined with base map layers from multiple sources in a single map display. In this video, we'll be seeing four different functions of this toolbox. Firstly, we'll be seeing how we can create maps using MapShow. Next, we'll see how to display a rotating globe. Next, we can create an interactive globe where you can select the cities and know its name and latitude and longitude locations. Fourth will be an application of this toolbox which is relevant to the current situation. That will be visualizing the COVID-19 cases of each country and plotting it in a map. Now we have seen a basic introduction about what a mapping toolbox does and also what we can expect in this video. So the first thing that we'll be doing is to creating maps using MapShow. Let's move into the code. We have the script ready to show how to create a range of different maps using the MapShow function. Firstly, we have the CLC, clearAll and closeAll functions. Then the first map that we'll be trying to project will be the road map. We'll be displaying a geographic data structure array with lines which will be representing the roads. The input file that we'll be taking in will be a .shp file. .shp file means a shape file. Let's see what a shapefile is. The shapefile format is a geospatial vector data format for geographic information system software. The shapefile format can spatially describe vector features like points, lines, etc. and each of those features will be example, like it will be representing a water well, a river or a lake, etc. Each item usually has an attribute that it will be describing in a map, such as a name of a place or the temperature of that area, etc. Going back to the code, we have the .shp file of the roads in a city called Concord. Concord is the name of a place and hence the roads are stored in a data array called .shp. Now we are using a figure and in that figure we'll be displaying those roads, and for that we are using the MapShow function and we are labeling the X and Y parts. Now we'll run the code and see the display of the roads. So here we have the roads of the place which are displayed. As we click the image, we are also able to see the coordinates. Now moving on to the next part of the code, where we'll plot the same roads with the custom line style. So in the previous thing, the lines were the default lines, and this time we can change the style of the line. Here we have mentioned colons. So the lines will be displayed as colons. We'll continue running it and let's see how it is displayed now. So this time it is similar to the first one except for the lines which are represented as colons. Like last time, this time also we are able to see the X and Y coordinates. Moving on to the next part. Our third map will be to display the road shape along with differentiation of colors. Like each different road type will be specified with different type of color. So for doing that, first we need to read the type of the roads which are present. To know what all types of roads are present, we need to read the Concord roads.txt file. So here we see that when we run the code, we are getting the details of the text file. Here we can see that there are 7 classes of roads that are present from 1 to 7, which are limited access highway to highway ramp. Next, the road admin types are 0, 1, 2, 3. So the roads are classified in this manner. In order to know how many roads are present in each class, we are using the hist function. Here we see hist counts, which gives us the counts of road. So we are finding how many roads are present in each class. Here we have the answer, and we can see that there are no roads present in class 1 and class 7. Similarly, we are seeing the roads of admin type. We are seeing how many roads are present in each type, and here we have the count. Similarly, we can see that there are no road types present in 1 and 2. Now, according to this, we can mark the map. By default, the lines will be marked in green color. And here we have each attribute following its value. Firstly, the admin type 0, we are giving the color black. And for admin type 3, we are giving the color red. For class 6 and 5, we are giving the visibility as off. Here we can see that class 6 and 5 are minor streets or roads, and we are neglecting them since they are just minor streets. Hence we are giving the visibility to be off. For the remaining classes from 1 to 4, we are giving the line width to be 2. Now using map show, we are again plotting it. Let's run it and see. Now here we have the roads. By default, the roads are in green color. The other class roads which we wanted to plot are in black and red color.
With the advent of fast, inexpensive digital computers, the role of numerical methods in engineering and scientific problem solving has exploded. Because they figure so prominently in much of our work, we believe that numerical methods should be a part of every engineer's and scientist's basic education. Just as we all must have solid foundations in the other areas of mathematics and science, we should also have a fundamental understanding of numerical methods. Join our premium online course on numerical methods, study online, and earn the certificate after completing the course.
Next, moving on, we are going to display the GeoTIFF image of Boston. Before going to the code, let's see what a GeoTIFF file is. The TIFF imagery file format can be used to store and transfer digital satellite imagery and other scanned maps. GeoTIFF is a TIFF file that has a geographic data embedded with tags, such as a TIFF file with a geographic data will have tags of the name of the places, the temperature of the place, and many other attributes, etc. attached to each place as a tag. So a TIFF file with a tag will be known as a GeoTIFF file. That is, a geographic data of a GeoTIFF file can then be used to position the image in a correct location and geometry on the screen of a geographic information display. In the figure, we'll be showing the map of Boston. So the place Boston has a boston.tif file. Now there's a shape file again which has the place names of Boston stored in it. So we are again using the shape_read command to read that shape file. Along with the map of Boston, we are also placing the names of the places. We are calculating the unit ratio of the map areas so that it can be labeled. Now each place name, the text of each place name is displayed near its location. Now let's see this map. Here we can see that the map of Boston, which is the background, has been labeled with the place names in its particular latitude and longitude location. Moving on to the next part. Once again, let's see all the maps. Firstly, we have the map with the roads. Next, we have the map with custom line style. Next, the maps with corresponding color to a particular class or type. Next, the map with the name of the places. So in this we have seen few types in which the maps can be plotted using the map show function. Firstly, we saw how to create maps using map show. Now it's time to move for the next code. The next code that we'll be looking at will be displaying a rotating globe using mapping toolbox in MATLAB. In this script, we'll see how we can animate to produce a rotating globe using the mapping toolbox of MATLAB. First, there are the CLC clear and close commands. Next, we'll be setting up a globe display. The view will be similar to a view which we'll get when we see a globe from above the North Pole. It will look like a 2D circle which has various circles inside it, which are the axes. So first, we are creating a figure and we are using the axis m function. Let's see what an axis m function is. An axis m function is used to create the map axis, and it has a predefined property named globe which will give us the axis of the globe. Next is the grid m function. The grid m function will be used to provide the map axis property name along with its property value. And here we have various properties set. The line of the axis, the line style is specified as hyphen. So the map axis will be displayed as hyphens together, which will be similar to a normal default style. Then the globe color, the G color is selected to be 0.7, 0.8 and 0.9. Next we have the grid property which we have set it to be on. The next step will be to spin the globe for 1 revolution, and we have the set function for it. Similarly, the set function also has few properties and the property values. The box is set off and the projection is given as a perspective. We are using the spin function. Here we have the spin function in a separate MATLAB file. This will rotate a view around the equator for 1 revolution, and it normally rotates from west to east, and we are using the for loop for this purpose. Our next step will be to add a base color and again spin it, but this time at a lower rate. For this we will be using the setEm function. As we see here, the setEm function has the map axis property name and the property values. And in this case, we'll be using this particular setEm function, which will use the GratiQ.
What are you planning to do in the upcoming vacation or free period? Get trained in MATLAB and Simulink from MathWorks certified MATLAB experts at MATLAB Helper. We provide learning from basic to the advanced stage. Our training modules include fundamental to advanced MATLAB, building prototype with MATLAB App Designer, modeling and simulation with Simulink, image processing and computer vision, hardware interfacing of Arduino with MATLAB and Simulink. Choose your training plan and give a boost to your MATLAB skill.
We have the setEm function and also the spin function. We are adding a base color of copper color here, and the copper color is specified to be in this RGB values. Next comes the CLMO command. This is to clear. From here we can see that the CLMO commands deletes all the displayed graphics which are on the current axis. As we delete all the previously given properties, we have the copper color which was given as a background deleted now, and we are giving it a feel like Earth is in space, so we'll blacken the figure background and turn off the 3 axes. After turning off the axes, we can now spin the globe again. Finally, we'll be applying lighting. The lighting would shift as the planet rotates, so making it more brighter. Let's run to view the results. As we saw, first we had a simple axis as we see it from above the North Pole. Then we had a globe with just the axis spinning. Next we had a base color added. Then we had the earth colors along with the globe kind of display with the water, land, etc. and with a black color background to give it a feel of a space. And finally we have the lighter portions and the darker portions which displays the terrain of the particular area. To have a more detailed view, I have created a live script which will give us which will be easier for us to have a look at each figure separately. Now I am running it. Firstly, the simple axis. Then we have the spinning of the axis. Then moving on to the rotation with the base color, which will be a copper color. Moving on again, we have the earth spinning in a black background with its landscapes visible now. and we have the final image here. So the difference between the previous image and this image would be that when we take the continent of Africa as an example, we can see that the entire region is almost in the same color of green. But here we see that the green color has become brighter in a few regions and dark in a few other regions. This displays the terrains. And also one more difference that we can see here is we have the Himalayas mountain. Here we can see that the terrain has been highlighted, and also due to the high altitude of the Himalayas, we have this place having a bit greater altitude compared to the other places, like it is a little bit bulged out compared to other places. Here we have the final illuminated version of the Earth, that is the rotating globe. Now we have seen how to display a rotating globe using animations in Mapping Toolbox. Let's move on to creating an interactive globe where we'll be able to select a dot in the particular latitude and longitude of the globe, and it will display which place it is corresponding to. This is the script for creating an interactive globe using the Mapping Toolbox. So in this script we will see how we can construct a map of major cities in the world along with the coastlines and terrain as we saw it in the previous example. And one more feature of this script is that we can interactively select a location and we'll get to know the latitude, longitude locations along with the name of the location. So first step would be to set up a map access object and render a global elevation grid. So this is first we'll be setting up the axis of the map along with a 1x1 degree elevation grid. For constructing the axis, we have the axis M function and it is Bryce. Bryce semester projection is a kind of projection that we are selecting. In this projection, the entire globe will be shown as a 2D figure with more emphasis on the land part rather than the other parts. We also use the frame M command to set the frame, and the width of the frame is also selected here. To display a 1x1 grid elevation, first we are loading the topo. Next, GeoShow command is used. GeoShow command projects and displays the latitude and longitude vectors using the projection stored in the current set of map axes. So the current set of map axes is the Bryce semester projection, and for the current projection it will be displaying the latitude and longitude vectors. Next step would be to improve the terrain display. Like last time in the last code, we made it a bit brighter with highlighting the particular terrain. So we'll be getting a color map which will be appropriate for each elevation. So here DMC map of topo will give us the colors of our earth, which is green in land areas and blue in water areas, and also making it a little more brighter. Next we'll be adding the coastlines. So for that we'll be loading the coastlines. So load coastlines command will be loading it, and then the latitude and longitude directions positions are given, and reduce M command is used to generalize the coastlines. The coastlines are plotted in brown color, so the color is specified here with the RGB values, and the line width is also given here. Again we're using the GeoShow command for that. Next will be to plot the city locations, and we are doing that with red point markers. There is again a shapefile which is inbuilt in MATLAB which has the name of the cities around the world. Not all cities are present, a few major cities might be present in that, and their coordinates, which is the latitude and longitude location. So using shaperead command, we'll be reading the shapefile. Now we are extracting the latitude and longitude locations using the extract field command, and we're adding it to the present map that we have. So we are using the geoshow command, and we are adding the latitude and longitude, and we are giving few attributes to it, like display type as point, marker as in a circle shape, marker edge color as red, face color as red, and size as 3. The text, this will be the text displayed as a title. So next step, we'll be having a step to select the cities interactively, so that when we click the particular red color dot, a city closer to that particular location will be displayed along with its X and Y coordinates. So we are setting the run city selection loop to true, so we can select any number of cities, and the selection will stop only if we press enter. So this is the text that is displayed. Next, input M of 1. If is selected latitude. If is empty, that is if enter is pressed, then we need to break the loop. First, D is the distance between the latitude, longitude, and the selected latitude and selected longitude. So when you place the cursor at a particular place, and that will be the selected latitude and longitude, and find D. D will be the distances of the point that you have selected with all the red points that are around. So that will be the distance D array, and in that D array we'll be finding the minimum distance. So when you place your cursor at a particular point, then these in the surrounding areas, the point that has a minimum distance with the selected point will be your city. So K will be the minimum distance, and that city corresponding to that distance will be found and stored in city. So now the latitude and longitude location of that city is found, so that it can be showed in the geoshow command. Again, the same kind of attributes are given. This can be given according to your wish. These are just the color and display attributes. The city's name and the city's latitude and longitude location is also displayed. So this is the end of the code. As we have seen here, the first one will be a text which says click on a dot for its city name, press enter to stop. The next text will be the city's name, here we see H2, and H3 will be the city coordinates which will be displayed. So I'm running it.
MATLAB Helper regularly organizes monthly quiz contests with unique benefits for our first few winners. One of our famous MCQ quiz is on coronavirus and MATLAB, conducted in April 2020. Read the testimonials from some of our winners. If you find it interesting, visit our website and test your skills now. You can book a certificate after the successful completion of the quiz.
So here we can see that the globe is represented in a two-dimensional surface, and this is called the bisemester projection, where the land area occupies the center of the attention. So in case, for example, I am selecting this point. So if I am selecting this point, then the points closer to that, the points which has the least distance from this point will be this. So the latitude, longitude and city name of this point will be displayed. So I'm clicking here. You can see that the city name of this point is displayed. Similarly, if I click here, we can see that the city name along with the latitude and longitude locations are given. So when I click in a particular place, the city nearest to that will be selected and displayed. We have seen how we can create an interactive globe using the mapping toolbox, and also we saw how we can select the cities and know its name and latitude and longitude locations. Now let's move further to the next code. We can see how we can visualize the COVID-19 cases in a map using the mapping toolbox. Let's move to the code. We have the script to visualize the COVID-19 cases in a GeoBubble map ready. Firstly, let us know what a GeoBubble map is. A GeoBubble map is where the data will be plotted using bubbles. For example, in this case, we'll be plotting the COVID-19 cases, and the bubble size would increase as the number of COVID-19 cases increases. And also, we can give different colors according to the severity of the cases. Now first we have the CLC clear and close commands. Then we'll be getting the data of the countries. For this purpose, I'm using a function which is COVID-19 data. Let's see what that does. Here in this function, it will return the table overall A. Using the webread command, we'll be reading the data from a web page. This web page contains the data of a spreadsheet which has the details of the updated values of coronavirus cases across the world in different countries. So for getting the details, we are using the for loop. We are taking the detail and storing it in 4 different columns. So first column will be the country name. Second will be the updated time, that is when the data is updated lastly. Next will be the number of confirmed cases, and next the number of deaths. So after obtaining these data from the given URL, we'll store it in these columns, and then finally we'll create a table out of these columns and name it as country, updated, case and death. These are the headings of the columns, and we can give it according to our convenience. Now from this function, we'll get the table overall A. So here, coming back to our main code, we have table overall A here. And now moving to the visualization part. The previous table that we saw had the country's name along with the number of cases. So this table will contain the coronavirus details. We also need one more table which will have the latitude and longitude locations of a particular country. For this we have this URL here, and from this we'll be getting the data. I already have stored an Excel sheet in MATLAB helper path, and that will have the geographic locations of a particular country. Let's see the Excel sheet. So in this Excel sheet we can see the country's name, a short form for it, its latitude locations and longitude location. We have all the countries stored here, and we have them in alphabetical order.
Are you looking for expert assistance in a long-term project, a thesis, or something else? Are you letting MATLAB delay your project? Is MATLAB holding up your task? Choose our affordable research assistance plans to get direct assistance from certified MATLAB helpers in your field. Get our research assistant plan to let us do the hard work in MATLAB while you do the hard work at your organization. You are just a click away from help. Book research assistants today.
In the code, we'll be reading the Excel sheet geolocation and converting it into a table. So for that we are using the read table command, and the new table now is named as table location. Using for loop, we are now matching the table location and table overall. So from table location and table overall, first we'll find the index of a country and match them. Using string compare, we'll be comparing two countries in each table, table location and table overall. When we find that two countries are same, we get their index and store it in a variable name as index. So using that index number, we can now get the latitude and longitude location of that particular index value. So for example, we have taken India and find its index and now find its latitude and longitude location from the table location, and we are storing it in latitude and longitude variables. In case the country is not to be found, then by default we'll store it as 40 and 150. Now we are creating a new table with the required parameters and we'll name it as geotable. For this we'll be using the table of command. This table will not have the details of the name of the country, etc. It will only have the details of latitude, longitude and the overall case. Next, we are naming the variable names as latitude, longitude and case. This is the title of the table columns. Opening a figure. Now we are using the GeoBubble command for plotting the GeoBubble map. GeoTable is the table name that we have created, and we have latitude, longitude. We need to mention the size variable parameter. That is, when we create the GeoBubble map, I already mentioned that the size of the bubble will vary according to a particular parameter. In our case, we want the size of the bubble to change according to the number of cases. So we have given it as size variable as case. Then we are giving the title for the map. We have named it as GeoBubble map for COVID-19 confirmed cases. And next, the size of the bubble should increase according to the severity. And here we are mentioning the severity so that it can be marked in different colors also. So for each color we need to specify a particular range, and for this we'll be using the discretize command. So as the overall table, we are taking the number of cases and discretizing into different ranges. For 0 to 100 cases, we are categorizing it as low, and we are mentioning it as categorical property and giving the ranges. So 0 to 100 will be low, 100 to 500 is medium, 500 to 1 lakh will be high, and 1 lakh to 20 lakh will be super high. In case if the number of cases is more than 20 lakh, then we have not mentioned any category for that purpose. So if it is more than 20 lakh, it will be given as undefined. Now we are giving gb.color variable equal to severity. So that means we have defined the severity here, and the color should vary according to the severity. This is from the code part. Let's try running it. One more thing is that in this COVID-19 data function, we are web reading it. That is, we'll be reading a web page for the data. So hence, when we run this code, we'll be requiring the internet connection. Let us run this code. It's taking some time to run. Okay, now we have the map. So in this map we can see the severity, as we had mentioned: low, medium, high, super high and undefined. We have the color codes here and the cases also, which mentions the size of the bubble. So if it is in this size, then it means that the number of cases is this, that is 3.43 into 10 power 6. We can see that each country has its own color. In India, we can see the latitude and longitude locations mentioned along with the number of active cases, that is the confirmed cases. We can see that it is nearly 9 lakhs. The severity is super high, since we had mentioned the range. If it is more than 1 lakh, it will be super high. If we see for USA, we can see it is in green color. The cases is mentioned as 34 lakhs. So it is more than 20 lakhs and hence it is given in green color, which is undefined. Similarly, we can see for other countries also. We can also move this map . So now we have plotted for the COVID-19 confirmed cases. In case we would want to plot for the deaths, then we need to make a few changes here. Let's take a look at the table overall A. We are able to see the table now, which has the country, the updated, the cases, the deaths. So we can see that we have here plotted for the cases. Now in case we need to plot for the deaths, then let's make the changes now. So here, instead of case, we'll be giving it as death. And here also we need to change it as death. Since the number of deaths are not as high as number of the cases, we can reduce the ranges. 100 can be reduced as 10, 500 to 50, 1 lakh to 10,000 and 20 lakhs to 2 lakhs. And also the title, we can change it as COVID-19 deaths. So we can run it. Okay. So here we can see that the severity, the color code is the same, but since we have changed the range, it might be different. And in the number of cases, we can see that the size varies from 1 to 13656458. And last time we saw that USA was in green color. This time we see that it is in purple color. We can see that the number of deaths are 23,000 in India, and in US it is 1,36,500, and it's given as super high. Since the deaths are greater than 10,000, it is mentioned super high here. So similarly, we can vary the parameters for which we are plotting the geo bubble. and the GeoBubble can be plotted for any parameter that you would like to. Not just for the COVID-19 cases, it can be used for various other data also. You just need to change the data from where you're importing it and the Excel sheets. The process is the same, and the command that we'll be using is a GeoBubble command. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post it in the comment section or get in touch with us. Follow us on LinkedIn, Facebook, and subscribe to our YouTube channel. Education is a future. MATLAB is a feature. Happy MATLABing.
Hello everyone, I am Mayuri from MATLAB Helper. I want to thank you for being part of our webinars, quizzes, and courses. We are doing a series of 5 webinars followed with live interactive sessions. I am hosting the webinar on image processing using fuzzy logic on 5th of September. 5 best comments from my webinar and live interactive sessions will be awarded with free access to 1 premium course with certification. Join my webinar to learn about Introduction of Fuzzy Logic Toolbox in MATLAB. What are the different image processing techniques? Application of fuzzy logic in medical image processing. Know more by visiting my webinar page. Test your learn skill with participation in the free webinar quiz. Thank you. Stay tuned.